Tell me why. Welcome everybody and happy National Science Day to all of you. We are here to listen to Professor P. Ajith deliver the IIA National Science Day lecture for 2024. But before that, let me tell you a little bit about Science Day itself. As you all know, National Science Day is celebrated on 28th February every year to mark the discovery of the eponymous C.V. Raman effect by Professor C.V. Raman in Calcutta at that time, for which he won the Nobel Prize later on. This is celebrated across the country with research institutions as well as other science communication groups throwing open their doors. All research institutions are open to the public on this day, and usually few hundred to few thousand to few 10,000 people then go and look at what is happening there, explore the labs, get to know what happens, talk to various scientists, and it's a public festival of science. Science Day is technically to commemorate a particular discovery in time of C.V. Raman, but then the National Science Day as this practice has come to mean much more. In particular, two things. One is that science belongs to the public, and therefore this one day, at least one day in a year when research institutes are open to the public. Science is financed by the public, science is meant for the public, and therefore science should be open to the public, and there's at least one day when anybody can walk into any lab and then find out what's happening and be a part of the process of discoveries in science. The second part of National Science Day is also to talk about what science means. It's not just about making a discovery and getting an award. It's about a method, it's about a process, it's about what we call the scientific method, it's about a perspective called scientific temper, and that is what I think we are going to have Professor P. Ajith here to talk about today for us. Yeah. Ajith did his master's from Mahatma Gandhi University in Kottayam in Kerala. He did his PhD at the Max Planck Institute for Gravitational Physics in Hanover in Germany on gravitational wave physics. He did his postdoctoral fellowship at Caltech with both the LIGO group and the theory group. And he's been in the International Center for Theoretical Studies, the IIFR in Bangalore, North Bangalore, since 2013, which you might be able to travel to if you have 2.5 hours or 3 hours to spare at some point. I'm very happy to have him here. He came here in the morning and he's been interacting with our students, especially the two team, since after lunch, and we're very happy to be here to talk about the second important perspective on Science Day, which is that of scientific temper and scientific method. He himself works on gravitational physics, especially theoretical modeling, data analysis, tests of GR, and lensing, recently lensing of gravitational waves itself. He's part of the Breakthrough Prize awardees for LIGO detection of gravitational waves. He's a young scientist awardee of the Third World Academy of Sciences twice, and recently, a month ago, he was awarded the Lakshminarayan Nagalakshmi Madali Award at the ASI, which I think many of you were at as well. Apart from his work in gravity, he's also very passionate about outreach and science communication. He's given many public talks. He was the main organizer of a fantastic online exhibition called Cosmic Zoom during COVID times and I think it's still there online. I urge you to go see it. It's a brilliantly put together online science exhibition. It's very interactive. He's also interested in the art science boundary and scientific temper. And he also supports and works with many other science communication groups, including the planetarium here, the Shastriya Parishad for those of you from Kerala and others. So I'll ask Ajith to now talk to us about science as a candle in the dark, which as he himself claims is plagiarized from Carl Sagan's book of the same name.
Thank you, Neeraj. I would like to start thanking Neeraj and the IIA for this very kind invitation. I've been to IIT many times and I've given several talks, but mostly on my professional work. And I thought it's a great opportunity to talk to the colleagues. Taking a step back and thinking about what is the wider context in which we do science and what are the kind of broader implications of that. So I'm very grateful for giving this opportunity. And I see this as a very friendly audience. And I prepared this talk keeping a sort of popular audience in mind, so I apologize in advance for the level of the talk, which you might find very obvious and too basic, and feel free to fall asleep. I wouldn't take any offense. So as scientists, we are sort of used to doing certain things because we are brought up in a certain way, and we are we learn what we do by a lot of things, by, of course, after the university education, by a lot of apprenticeship. The kind of techniques that we do and master, etc., are learned through apprenticeships. And often we don't step back and think about what exactly we do. It's usually the job of philosophers of science, etc. And I'm not a philosopher of science. I have no background in philosophy. So it's just like, so what I know about science is like just like what a musician knows about sound, or an artist knows about chemical science of colors, etc. So it's a very, in that way, this is going to be a very unacademic talk. It's some sort of, some random thoughts of a working scientist on science. So that I wouldn't claim any rigor in whatever I say here, although we try to achieve rigor in our professional work. So the broader context is what Neeraj described. Right? We know that, I think everyone in this group, in this hall would agree that modern science is a very successful way of creating knowledge. In fact, it is likely the most successful method that we have discovered as humanity over the last few thousand years. Because the kind of breakthroughs in our understanding of the world around us, it went through a dramatic change in the last 400 years. Of course, it is built on several thousand years of earlier work of humans, and like Newton would say, we're all standing on the shoulders of giants. But the pace in which our understanding has expanded, the horizons of our knowledge has expanded, has changed dramatically in the last 400 years, which is what we call the modern science. So, what exactly is the aim of science? And one sort of working definition is to organize facts about the material world into some universal concepts. It's not just about a body of facts, but we have certain way of organizing these facts so that one can be derived from the other, etc. There are some universal concepts. From using some universal laws, universal concepts, one is able to derive facts about the world around us, and also to collect and organize them. And a systematic way of doing this is what we call the scientific method. And there are at least two things that are very important in this practice of modern practice of science. One is that the domain of study is limited to material world around us. And since the domain of the study is the material world around us, the explanations also have to be found in the material world. One cannot invoke a supernatural explanation to explain the material world around us. One cannot invoke a holy book. One cannot invoke authority. It's not on the Zoom. Okay, sorry.
Share screen.
Oh, you have to enable me the screen share.
Sorry.
No, it's okay.
You can share your share.
Yeah, okay, yeah.
Okay.
Yes, yeah.
Okay.
So this is very different from the earlier systems of knowledge that pre-existed the modern science, right? Because there have been several ways of collecting and organizing knowledge for a long time, but most of them invoke some authority or things like, like for example, religion. For example, it has been a very powerful way of understanding the world around us, but it has a very, modern science has a very remarkable difference, which is that one cannot invoke a holy text or a material, supernatural explanation to explain the world around us. And this is actually less rigorous than what is called a pure naturalism. This is called methodological naturalism. And pure naturalism is a firm belief that what exists is just a natural world, and there's nothing supernatural around it. For example, atheists, etc., are naturalists in that way. But scientists need not be atheists. So it is just while practicing the science, one cannot invoke a supernatural explanation. It's very cleverly put forward by J.B.S. Haldane, who was a very important biologist of British origin, but actually he died as an Indian, so he spent a lot of time in the Statistical Institute in Kolkata and became an Indian citizen. So he put this in a very clever way. He says, my practice as a scientist is aesthetic. That is to say, when I set up an experiment, I assume that no god, angel, or devil is going to interfere with its course. This is different from saying there is no god or angel or a devil. I'm just not addressing that point. But when I'm setting up an experiment, I'm assuming that God or angel or devil is not going to interfere with my experiment. It's a methodological naturalism. And second is that science has an intrinsic error correction mechanism within it. The success of a scientific theory is determined based on how well it can explain the phenomena in the material world. So explain phenomena means it could be through experiments or observations. And this means that all the theories are tentative. No theory is final. The only, as scientists, we are not committed to any theory. The only adherence is to the methodology. If a theory is found unable to explain a certain observation, even though it has been, it is able to explain all the observations, if it fails to explain at least one observation, that means that the theory has to go. It is not the final theory. So there is an intrinsic error correction mechanism built into science. Even though as individuals, we may have our own biases and personal interest, because if I have a theory, I would like to believe that is correct, even though it is against the several observational evidence or experimental evidence. Science as a project will not listen to me. If it has to go ahead, basically that the history of science is basically littered with discarded theories, as we know. And so this is again very famously summarized by Karl Popper, an important philosopher of science, who put forward this idea of, which reasonably explained the current practice of science, which is called a method of falsification. He says that basically one can never prove a theory right. One can only try to falsify it. However, proofs that you have a theory, it doesn't mean that it is the final theory. But even if you have one observation that falsifies it, it is wrong. We can only try to falsify theories. So he also says that every explanation may be further explained by a theory or a conjecture with a higher degree of universality. What we are trying to bring is to make more and more universal explanations, so that one could derive the final hope is to have a final theory of everything, right? And the hope is that one could derive everything from that. It is a bit abstract, but one could, let's look at one particular example that all of us are familiar with. And in some sense, the physics is a prototype of this methodology of science. In some sense, because it's the simplest of sciences. It has the largest degree of universality, and in some sense, it deals with simpler systems. It's very different from, for example, biology, which is a very complex, try to explain complex phenomena, or social sciences, which is try to explain even more complex phenomena. But physics is simpler. So in that sense, sort of a prototype for understanding methodology of science. So, and there's nothing better than looking at the history of astronomy in its effort to understand the cosmos. We know that at least the last few thousand years, humans have been trying to understand the motion of planets around us, and various contributions from societies across the world, including India, Greece, and Hellenistic Egypt, China, Mesopotamia, all over the place. In some sense, but all of them have something in common, which is that the Earth was center of the solar system, which was very obvious thing to do, right? Because what we see is we don't see any effect of motion of the Earth, and we see everything revolving around the Earth. It's a natural thing to do. It's not that these people were not smart. They were very smart who tried to model these astronomical phenomena. But as we know, to explain this seemingly erratic motion of planets in the sun, they had to come up with some very sophisticated, not only sophisticated, but also very complicated mathematical models. For example, they involved things like epicycles, right, where the planets are not only orbiting the Earth, but also they had some internal sort of motions called the epicycles. And it had a very complicated mathematical model, and it was with these mathematical models, these astronomers were able to explain the observations reasonably well, although there were discrepancies, etc. But there was only a simple change that Copernicus made, right? Just instead of putting the Earth the center, he basically moved the center of the solar system from the Earth to the sun. And then it made the motion of the planets, essentially it's a very simple mathematical model, and it could explain the observations extremely well, better than these earlier models. So what we are achieving here is a simplicity. This is again something that from this extremely complicated models, just by changing the center of the solar system from the Earth to the sun, one is able to come up with a equally good explanation, equally good predictive power using a much simpler model. This is something that these days we call the Occam's razor. If there are multiple explanations to the same phenomena that have the same level of predictability or explainability, then we prefer the simplest of this. Again, Kepler, as we know, revised this model by making them as elliptical orbits. But not only that, he was able to derive simple empirical laws that precisely described the motion of the planets. The second law tells that there is a equal area theorem, and then he also has this third law that describes a relation between the semi-major axis of these orbits with the orbit period of planets. So these models are able to make much more quantifiable predictions using some simple underlying physical or mathematical laws. There is still not yet a physical explanation of what is causing this motion of the planets, etc. But still, there is a much larger degree of universality in these expressions. Then this next really remarkable breakthrough came from Newton, who said that it is the same force that is responsible for the fall of an apple. It is also responsible for the motion of the planets around the solar system. So one is able to derive a physical law that is valid not only here on the Earth, that is causing the fall of the apple, but the same universal law works across the universe. It is also responsible for the motion of the heavens, motion of the planets. It's very different from the philosophy of the time, right? Because, for example, the ancient Greeks believed that the rules of the heavens are different from the rules of the Earth. So it was a very brave and a great leap in their understanding that one is able to come up with a universal law that describes the motion of basically everything in the universe. But does it mean that it has and it also has a lot of predictive power also. For example, we know that the only source of gravity in the solar system is not the sun, like our standard Kepler problem, but all the other planets, especially the heavier ones like Jupiter, add perturbations to it. So one has to precisely explain the orbits of these planets, one has to take into account the perturbations of these other planets. And now, using the observed planets, one was actually able to predict the existence of new planets also. For example, the existence of Neptune was predicted from the motion of of Uranus because of this Newtonian perturbation theory. Right? So the theory is not only able to explain the observed motion of planets, but it also was able to predict the existence of new phenomena like a new planet, which was subsequently observed by astronomers. So it's a next level of greatness of a theory. It has a predictive power. It is able to predict new phenomena which one could go ahead and observe and verify. But again, we know that the history didn't stop there. It was not really the final theory. And the big difference came from the orbit of the Mercury. Right? The Mercury, unlike most of the other planets, it does not have a closed orbit. It has a precessing orbit like this. And most of this precession comes from this gravitational perturbation of the other planets like Jupiter and so on. However, even after including all this perturbational effect, one could not explain the observed orbit of Mercury. Then astronomers predicted the existence of a new planet, just like they tried for the case of the Uranus, and tried to look for this. They even named it. It's called Vulcan. And then a lot of effort was spent in searching for this new planet with no success. But then came Einstein. So he came from very different reasons. His primary concern was the incompatibility of this Newtonian gravity with this theory of relativity, which basically says that no information can travel faster than light. But according to Newtonian gravity, the information travels instantaneously, right? There is no time lag in the propagation of gravitational force. If, for example, if you take away the sun, we would know its effect immediately, according to Newton's theory. But the special theory of relativity says that information cannot travel faster than light. So there has to be a delay of about 8 minutes. So that's the motivation was Einstein. But then he was able to come up with a new theory of gravity, which described gravity in terms of the space-time's curvature. Any massive object would curve the space-time around it, and basically all the motion of objects, like the planets, could be derived from this. In fact, all the Newton's laws could be derived from an approximation of Einstein's theory. And it successfully, and when these Mercury, in a planet like Mercury, is closer to the gravitational field of the sun, where the gravitational effects are stronger, and hence the corrections to Newtonian gravity will be stronger. And that is causing this observed difference between the Mercury's orbit from the calculation using Newtonian gravity. So his theory was actually able to explain the orbit of Mercury extremely well. But again, it was also able to make new predictions, just like Newton's theory did for the existence of Neptune. So one such prediction was that gravity actually bends light. So we know that light travels to a straight line. That's because the space-time is reasonably flat here because of weak gravitational fields. But according to Einstein's theory, when the gravitational fields are strong, the space-time curvature is strong, basically light travels to the shortest distance between 2 points. And in the case of a curved space, that shorter distance is not a straight line, but it could be a general geodesic. So, and that can have an actual observable implication. So, for example, here is a cartoon of the space-time geometry around the sun. And if there's a distant star whose rays are raising the limb of the sun, they would be bent by the space-time curvature of the sun. And an observer who is sitting here would see a shift in the apparent position of the star. And there is a cartoon version of what would happen. So this was first observed by, as you know, Eddington and his colleagues in 1919 solar eclipse. So what they did was to photograph the position of stars in the Hyades cluster, and that is shown by these red stars here. And then they compared this image against a reference image where they took the same photograph of the same cluster of stars in the night sky when there is no sun in between us and this star. And that is shown by these blue markers. And they could observe that during the solar eclipse, the position of the stars have shifted, And one could calculate the amount of the shift of the position of stars due to the gravitational bending of the sun, and it agreed really well with the prediction by GM. And there is Eddington, and it's one of the actual photographs from the 1919 eclipse. So again, the theory is making a new prediction, and it is totally unexpected in the other theories, the previous theory. But now it is they're able to scientists are able to independently verify a totally new prediction of this theory. So you're going to a more and more powerful theory. It is able to make predictions of a larger amount of new observational phenomena, which scientists can go ahead and observe. But again, this is only one of the many experimental predictions that Einstein's theory has produced. There are many things: existence of black holes, gravitational time dilation, things like expanding universe, etc. Again, all these predictions were so counterintuitive at the time that Einstein himself did not believe in most of these things. And for example, when he solved these Einstein's equations for the case of a homogeneous and isotropic universe, Einstein found that the universe could not be static. It has to be either expanding or contracting. So he has to put an extra term artificially because it's so counterintuitive that the universe would be so dynamic. And later, a decade later, Hubble observations actually suggested that in fact the universe is actually expanding. So the theory could be producing counterintuitive predictions, but one could actually go ahead and observe it, and it turns out to be actually correct. So far, Einstein's theory has passed all the observational and experimental tests with flying colors. But does it mean that this is the final theory of gravity? No, because we know that there are already we already know that there are problems with Einstein's theory because it is, for example, incompatible with the theory of quantum mechanics. So in microscopic phenomena, for example, in the singularities near the black holes, inside the black hole, or in the very early universe, the same phenomena, the strong gravity has to be merged with the physics of microscopic system, which is the quantum mechanics. And we know that there is an incompatibility between these two theories. There are some fundamental limitations to this theory that we know. There are also a variety of observational evidences. For example, recently, the last 3 decades, astronomers have found that the universe is not only expanding, but the expansion is accelerating. So which could be a possibility as a sign that Einstein's theory is breaking at some very large scales. So I'm saying that there are fundamental reasons to believe that Einstein's theory is not the final theory. There are possible observational evidence that suggest that Einstein's theory could be violated at some large scale. So we know that Einstein's theory is not the final theory. But still, it is an incredibly useful tool, right? Because we are able to explain a large amount of observational phenomena using this very beautiful and compact theory. And we are able to make a number of observational predictions, which scientists are able to verify through a range of observations and experiments. So it is, we know that this theory is tentative, but we still work with it. And that is how science works. Our explanations are tentative, and we are able to accept that tentative explanations because they are very useful. They have a predictive power. They are able to explain and predict new phenomena. And that has a lot of implications to the wider world as well. One is that the modern technologies, I'll describe in 1 minute. So in summary, the modern science's success in explaining the physical world is due to its willingness to review and refine based on observation and experiments. So it has an intrinsic error correction mechanism built in. It's very different from other forms of thought, for example, like religion, right? There is some absolute truth that is written, and the followers are not allowed to change based on observation and evidence, etc. So, and it has a number of implications. And one implication is that modern science has resulted in modern technology. So we have, if you look back at the history of science, there are a large number of examples. Any major technology, if you look back, has a root in a basic science discovery. So, for example, the Faraday's experiment has resulted in the commercial generation of electricity, which is something that we cannot imagine a world without. There is a story that, it's probably just a story, not true, but there is a story that, Faraday was a great demonstrator. He would do these great demonstrations, these Christmas lectures, etc. And apparently someone from the government, the minister or something, asked, it's all great, but what is it useful for? And apparently Faraday said, sir, one day you'll be able to tax it. So now, it's something that we all kind of work with. It's very hard to predict what is the use of something that we discover now, but in the next 50 years or so, there could be a possible effect. And if you look back in history, there are many examples. For example, Maxwell, you cannot imagine a world without telecommunication, telephone, radio, TV, microwave antennas, and mobile phones these days. And all has the theories coming from Maxwell's equations. And Maxwell was a totally asocial nerd, what we call these days. And he would not have thought that his theory would have such a large technological implications in next year. So, quantum mechanics, basically, all the electronics is basically based on quantum mechanics. In fact, there is some estimate that that quantum mechanics is worth a few $1 trillion of the economy. Even some very esoteric things like Einstein's theory of relativity that describe how gravity curves space-time and how it slows the flow of time. It not only has a great explanatory power in explaining some large number of astronomical phenomena, but it also has direct applications to technology these days. Most of us use Google Maps these days. It's very hard now to imagine a world without Google Maps. It uses a technology called GPS, the Global Positioning System, because we want to locate ourselves with the map. And that is done through a system of satellites called GPS satellites. And they all broadcast they form basically a coordinate system. And they all basically broadcast their position and their local clock's time. And if you are able to receive at least 3 such signals, you are able to triangulate yourself with respect to this 3-dimensional coordinate system. But so these atomic clocks are very, very precise, but they are orbiting the Earth a few hundred kilometers above us. So, right? So these clocks are all synchronized when they were flown on these rockets. But because they are experiencing a different gravitational field as compared to the clock on the surface of the Earth, they are ticking at a different speed. Actually, the time is flowing at a different rate on the surface of the Earth and as compared to the surface of the satellite. So this difference has to be taken into account for the GPS to work. Otherwise, the GPS would stop working within a few minutes of its operation. So this GPS receiver is actually taking into account this gravitational redshift as well as this special relativistic Doppler shift for it to work. So even that very esoteric theories it's a short amount of time has practical applications now. That's sort of one obvious thing that we all understand. But also, the use of the scientific method is not only limited to producing technology. I would argue that a lot of the social changes that happened, especially in the last century, was greatly impacted by the development of modern science. Because the scientific method, which is basically a method of inquiry and is based on reason and evidence, can be applied not only to the natural world, but also to the social phenomena around us, the social and economic phenomena around us. And this has actually impacted the social change that happened in the last couple of centuries. And there are several examples of that. But in particular, in India, there is this very important body of work by the early freedom fighter and an economist, Dadabhai Naoroji. Right? Because, as you know, the British ruled India for about 200 years. And at least in the earlier days, it was not clear whether the British colonial rule was actually of benefit to India or of loss to India. There were both kinds of arguments. For example, the British brought in the English education, railways, electricity, all kinds of things. So a lot of people thought that there's a good reason to believe that actually we are benefiting from having the colonial presence in India. And it was not an easy question to answer. But Dadabhai Naoroji did a very powerful and very detailed economic analysis and showed, and in fact argued, that the British colonialism is actually systematically draining the wealth from India and is causing the impoverishment of the people and causing the poverty, resulting in the poverty of India. So this very powerful economic analysis, this book is actually available on the internet. You can see it's a very technical economic book. And it actually helped building the ideological foundation for the Indian national movement in the early 20th century. So the point I wanted to make was that it is the use of science is not only in producing technology, but also, if you look back the history, it has a direct impact in resulting in social change also. And secondly, so that's sort of 2 points I want to stress upon. Then there are also conflicts with other forms of thought, right? For example, there has been at least historical conflict. But most people these days believe that, in fact, there is no such conflict between science and religion. Because as I said earlier, the domain of science is actually limited. Its job is to explain the material world around us. It has no particular stance on our values. Should we help our neighbors? Should we lie our neighbors? Should we do good? Should we? All these things are, what is good? What is bad? What is evil? These are all very hard things to define in science. In fact, science does not concern about such values. While it does not concern about our moral or ethical questions. It is beyond the domain of science. And many other forms of thought, like religion, it's pretty much it's a domain of their thought, like spirituality, what is beauty, what is truth, what is good, what is evil. All these moral and ethical questions are addressed by a lot of other forms of thoughts, like religion. And as long as these two reside in their own spheres of thought, there is no conflict between them. So this is primarily advocated by this evolutionary biologist called Stephen Jay Gould, who put forward this argument: this is non-overlapping spheres. Science and religion work in two different spheres that are non-overlapping, and as long as they stick to their own domains, there is no conflict between them. And but historically, there has been issues. You know this Galileo episode. All of you know how the Galileo's observations changed the worldview of the times and has brought in the displeasure of the Catholic Church and the history that followed. Because many conclusions of science on the material world are in conflict with a literal interpretation of the religious texts or conventional beliefs. In the case of Galileo's, I don't think there was any conflict with the religious text. It just was a conventional belief, that's all. There was a conventional philosophy at the time. But sometimes these conclusions could be in conflict with the literal explanation of the interpretation of the religious text also. So such conflicts have arisen in the past. But for example, in the case of the Catholic Church, the Catholic Church basically admitted that it was wrong to crucify, Galileo, and they basically moved on with the modern understanding of the universe. So many religious institutions have basically learned to adapt the change in the worldview based on the scientific discoveries of the material world, and they repositions that there is no conflict between the religious beliefs and the discovery of science. But in modern world, one do see various conflicts between science and various kinds of ideological beliefs. And it comes from even surprisingly so-called developed societies as well. And one such example is the resistance to the idea of evolution by natural selection, just sort of put forward by Darwin and Wallace, etc., but has been developed by a huge body of work in biology and related fields in the last couple of centuries. So basically, this is a theory that is able to explain the observations of the natural world most successfully. This includes paleontological evidence, physiological evidence, DNA, all kinds of things. And if there was a better explanation to these observed biological world, science would accept it. In fact, the current modern understanding of evolutionary biology is actually rather different from what Darwin put forward. There has been a large number of successive additions to our understanding of biology. For example, Darwin had no good understanding of how this hereditary traits are transferred. There was no understanding of genetics at that time. Genetics came much later. So the modern understanding of biology is actually a much more evolved version of these original thought by Darwin. So these explanations have been systematically undergoing revisions based on observations and experiments. And if there is a better theory, scientists would accept it. Maybe the individual scientists won't accept it, but science as a project would move on. That is something that we know. The conclusions of this evolutionary biology are in conflict with some literal interpretation of certain religious texts. And that has angered a lot of fundamentalists, especially in the US, for example, and other places like Turkey, etc. And there has been a lot of resistance to even teaching evolution in schools. And in places like Turkey, even scientists have been in jail for defending their science, etc. Another example, just more recent, is the resistance to the understanding of the climate change. Again, just like among the professional biologists, there is practically no debate that evolution is right or wrong. In fact, I think this is Haldane who said that nothing in biology makes sense without the light of evolution. There's practically no debate on the foundations of the evolutionary thought, but there are debates on the details of the thing. The same way, it is very well established that on average, the average temperature is increasing across the world, especially in the past 50 years or so. And that is primarily influenced by the presence of greenhouse gases in the atmosphere, such as the carbon dioxide, methane, etc. And the human activity has a great role in this. Again, among the professional scientists, climate scientists, there's no debate about this basic premise of this climate change. Of course, there are some details on what exactly is the impact, prediction of the future, etc. Here's, for example, how the average temperature in the world is increasing as a function of from the 1850 to early 2020s, and it's sort of from the last century you see a significant change, sort of almost reaching to exponential scales. And this is primarily correlated to the presence of the greenhouse gases. And from physics experiments, we know that these greenhouse gases has an effect of heating up the atmosphere by trapping the radiation. So again, there is no great debate on the fundamentals of this conclusion among professional scientists. However, there is a large group which put forward both an ideological opposition as well as opposition because of ideological as well as economic reasons. Because if you accept this as a reality, if the governments accept this reality, what would happen is that a lot of them would be pressurized to put forward various kinds of restrictions on the emission of these greenhouse gases, which would affect this large petroleum industry that exists across the world. So what is happening, especially in the US, now it's sort of declined a little bit, was that a lot of private think tanks have come up, and they are trying to put holes in the arguments and trying to find that this particular argument is wrong and so on. So there is kind of a large funded group of climate skeptics whose job is to kind of find holes in the arguments of these climate scientists. It is okay to have this debate, but usually it is not done in the right spirits. It is not following the rules of the scientific debate. So, and all these think tanks are primarily funded by large petroleum lobby. And there are also other kinds of ideological oppositions to this also. One is, there are a lot of these free market fundamentalists who believe that any kind of public or government imposition on the flows of market is counterproductive. The markets have to be left free, and they will do whatever they want, and that's the best way of operating the world. So they also find these sort of controls, by possible controls, etc., on emission, etc., problematic. And there's a large ideological opposition to this also. So what I'm trying to say is that mostly these sort of resistance come not only from their lack of their interest in improving the method or improving the knowledge, but they are worried about the implications of the scientific conclusions. How would that affect a particular interest? There are also, you would think that we are sort of isolated from these kind of issues, but there are also similar issues happening in India also. Usually the fields of science that are attacked in public are mostly the ones that challenge some dominant paradigm that exists in those societies, which could be, for example, the fundamentalism, Christian fundamentalism in the US, or market fundamentalism, etc. Luckily, none of these are a serious threat to any dominant forces in India. However, the scientific narrative of the history, some scientific explanation, some scientific pursuit of the history also come up with a lot of attack in the context of India. The reason is that we know that the human history is a very complicated thing. We have some broad understanding of how the humans and cultures and societies evolved. We roughly know that this Homo sapiens evolved somewhere in East Africa about a few lakh years ago, and there were several migrations happening across the world. Even to India, there have been several streams of migrations, starting from about 75,000 years ago to very earlier times. And there has been conflict between all these different kinds of groups and people, and different economic groups, religious groups. There has been historical conflict. But currently, there is a narrative that is very sectarian, that is just looking at this history, Indian history, from a very religious prism only. The very simplistic narrative history, which is used to propagate and justify sectarian ideologies. And the professional historians who actually look at history in a very reason and evidence-based ways, their work has been not only criticized, but also kind of resisted very badly in the more sort of public circles. So if you look at it, there is a commonality in all these three examples that I mentioned. Among the professional scientists who work on these fields, there are hardly no debates in the basis of their conclusions. There are issues on the details of this, of the latest frontiers, etc. Has happened in the case of physics and astronomy also. But broadly, they agree on the basic premise. But most of this resistance come from outside professional scientists because they are worried about the ideological content of these conclusions. And that has been happening more and more in the modern world also. So my sort of point is that the resistance to various branches of science in modern societies stem from concerns on the ideological consequence of scientific discoveries, not necessarily from an interest in improving the understanding of the world, which the science is doing anyway. So let me sort of end this discussion in the next 5 minutes on thinking about what is the role of scientific method in the new world. The new world has has a new word also. It's called post-truth. I think in 2016 or so, this was claimed as the word of the year, because this was this entered the Oxford Dictionary in 2016, etc. So there is a widespread phenomenon across the world where people respond to various questions primarily based on their prior beliefs or feelings more than facts. So most of us have a predetermined belief on certain things, we have predetermined position on certain things, and irrespective of the evidence contrary, we are not willing to change it. So in fact, we are good at filtering whatever evidence that is supportive of our views and discarding the others. And this is in particularly worsened by these social media networks. There have been several studies on the social media networks where people have found that people who think similarly are clustered in these networks. It means in WhatsApp or Facebook and other things, etc. So we get similar kinds of things, the things that we like to believe. And another group would get a different kind of things that they would like to believe. There is no common ground between them. There is no common fact that we agree upon. So we would like to believe in our own facts, which is different from a different group of facts. And this is something, we are entering in sort of this Babel's tower issue, right? Essentially, no one is able to communicate between each other because we have no common, common facts. There's no common way of understanding the world around us also. And this has sort of affected our life in various ways, and not only science also. And it's sort of important to think what is the way that we can solve this. So I think in this sort of that's thought I would like to sort of plant on this National Science Day. So the summary of this talk is that over the past centuries, humanity has constructed a systematic way of acquiring new knowledge that is based on reason and evidence. These are really two pillars of modern science. And at the core of this knowledge system is the scientific method. The science is not only just a body of facts, but it's a way of systematically collecting and enhancing knowledge. And the conclusions derived from this method undergo a systematic scrutiny and revision. Scientists should not have any adherence to particular theories. The only adherence is to the method. The theories will need to be revised at the light of new evidence. And this ability to understand the natural and social phenomena has resulted in significant progress in human societies because it has created modern technology, which has resulted in a large economic transformation of the world in the last century or two, and social transformation also. The Indian freedom movement is one example of that. And recently, we are actually risking. We are at the risk of losing some of this sort of progress that happened, especially the last century. And however incomplete, this method remains the best way of understanding the world around us. So, to borrow Carl Sagan's words, it is a candle in the dark. So I hope that we will have to think and see how we will be able to sustain this mode of thought and be able to apply it in all walks of life in our lives. So let me stop here and thank you very much.
Thank you so much, Ajith, for that talk, which kind of epitomizes the spirit behind Science Day. Just like you said at the beginning, an artist need not know about the theory of colors, but art is only better for knowing it. Same way, we may all be practicing scientists, but knowing about scientific method makes us better scientists. So I think that's something to go back. We're going to get questions. So we have some cool merchandise which we want to give you.
Thank you.
And you mentioned that though science is more objective, scientists may not be objective, and one of the discriminations or biases we have is about gender. There's a book here which is published by IAEA on women astronomers of IAEA. We hope you'll have a good read about that as well. we'll start with questions from the audience and move on to questions on Zoom and YouTube. I request people on Zoom and YouTube to type in your questions and we'll take them. People on Zoom can also raise your hand. First questions from the audience. Yes.
Hi. So you mentioned that Occam's razor method. So do you think it's a part of the scientific method to draw conclusions? And have you ever concluded in your papers based on Occam's razor?
Yeah, a quantitative way of Occam's razor is what we call the Bayesian odds ratio.
Okay.
Then you compute a Bayesian, so if you have two different hypotheses to explain the same observational data or experimental data, a very practical way of computing, doing the Occam's razor is computing the Bayesian evidence between the two hypotheses. And you can do a Bayesian ranking. It's in fact, a common practice in modern physics and astronomy.
Yeah. Here, you, and then Mahesh.
So, like as you have showed in the slide, that science ultimately lead to the new technologies, and that technology ultimately helps us to understand science better. Now, what happened is that also you mentioned the climate change graph. So, like because of the invention of these new technologies, we also are facing this climate change. So ultimately, if like, what do you think is the solution to this problem? Like, if we stop the carbon emissions, then ultimately it is also going to harm the understanding of the science. But then, if we do not stop the carbon emission, then as we know that global warming is going to take over and temperature is going to increase. So, what do you think is a plausible solution? What practical solution for the problem?
Yeah, it's a good question, but at least in this case, it is not that we don't have alternative technologies, right? There are possible limitations to this, but there are alternative green technologies which, without hindering significant economic progress, can be used to limit the carbon emission. One is the use of renewable technologies like solar and wind and so on. But also, we will have to be more, personally, I think that we will be more disciplined in consuming also, right? Because the consumption cannot continue to grow. There are practical limitations. So I think Mahatma Gandhi said, there is the earth has thing for everyone's needs, but not for greed. So as a society, we will have to have individual responsibilities for limiting our consumptions. But also, there are technologies that can reasonably meet these requirements as alternatives to the carbon-based fuels also.
Can I ask a quick follow-up question to that? So you addressed the question of climate change being a science problem. It's also a problem in science communication. Do you want to address that as well?
Yeah, so this is again one big issue is that as a larger mass of people, an immediate threat is much more easy to understand than a slow death. So if you count like the number of Hollywood movies made on extraterrestrial invasion and Jurassic, the dinosaurs and all kinds of monsters invading the planet, they would be many, many more times larger than any slow threats like the climate change. Because it's much easier for people to relate an immediate danger, like for example COVID or something, than a slow change like climate change. So it's a very good question to ask. I don't think I have an answer to it. How do we realize that basically what we're doing in this space has much more risk than some, for example, the possibility of an asteroid hitting the planet? These are something that people can immediately capture their imaginations on, but the slower deaths are much harder to digest.
So it's a challenge in communicating scientific method itself, right?
Yeah.
Which is the heart of this climate change tonight.
Yeah.
Mahesh.
Very informative talk, Ajith. Thank you.
Thank you.
It was regarding the point which you said about Dada and Naroji's book, where they're taking the cotton from India and bringing back the garments from Manchester.
Yeah.
Don't you think that the same thing is happening today with the software industry? in the sense that the software, many of the software is being written in developing countries and they're selling it back for a fortune in the same developing countries.
Yeah, yeah. So what is happening, unfortunately, is that because of this liberalization of the economy, the capital can flow very freely internationally, right? So wherever there is cheap labor, the international capital will flow there. But I'm not sure. This is it's a good point. We are essentially selling our cheap labor. Of course, it has helped our economy to be lifted and so on. But once, if there's another new market opens up, maybe in Africa or something, this capital would flow there also.
It's a very small percentage. It's not that the entire country is benefited out of it. So possibly, I don't know what's the solution that Radha already has mentioned in his book. Maybe you can think of that, or maybe tax it more of the feedback resistance should be more from the software industries who are using the brains like that. Maybe one of the solutions.
Yeah, it's a good question. I don't have a good answer to it. Yeah.
Thank you.
Other questions? Yes.
Like my question is kind of related to what you said about GPS using relativity. So there are 5 Lagrange points in total, and so I understand that we can still classically explain in a way the L3 point between Sun and Earth. It's L3. Okay. So how do we explain the other points?
The Lagrange points.
Hmm?
The Lagrange
Yes,
points.
yes.
So basically, you have to look at where the different forces compare or cancel each other, right? So it could be, okay, I have to revise my Lagrange points, but it doesn't need to be opposite also. So, one has to look at the gradient of the gravitational potential, how it goes to different directions, and you look at the null of that gradient of the potential. So it doesn't need to be, you have to have opposite pulls.
If I can add to that, I think that again comes back to the topic, even though we may not have meant it to be so, of science communication. Because while talking of Aditya, all of us kept telling the media that L1 is where the gravity force is balanced, and all the Lagrange points gravity force balance. Obviously, it does not, which is what your question, right? L3, L4, it doesn't balance. It balances only if you add the third component of centrifugal force, which you never mentioned to the media because it complicates things. So you simplify it, and then somebody always comes up, some bright student comes up and says, what about L3, L4? So you have to add the centrifugal force to the other two, and then it balances in the finals. Is that the question?
Yeah, okay. My final question was, so is it classically explained itself?
Yeah.
Oh, it does not require.
Yeah, you have to add the third force to balance, which we do not mention when we talk to the media or write popular articles because we don't want to complicate things. Yeah. Yeah.
So you mentioned. So you mentioned about scientists' way of scientists make the world for a better living, like make the humans have a better living. But I wanted to ask you, so science gives us facilities and convenience for a better living, but how does maybe it's a philosophical side? How does that ensure how behavior in a better way? Can science help in that?
No, not necessarily. Okay, science is in some sense very neutral in terms of values. However, understanding of the world that is gained through science can help us form values. So one great example is the understanding of race, human, right? So ethnicity or race. Now the term race itself is not used at all. The reason is that unfortunately there has been a history in the early last century where some rudimentary understanding of things like the selection, this eugenics, has been used to support the Aryan ideology by Hitler, Nazi party, etc. But however, in the middle of the last century, it became, so the idea of this Nazi party was there is a certain race that's called Aryans, which are supreme in terms of their capabilities, etc., as compared to other races. That is the understanding. And this whole ideology is built on this premise, right? But then later understanding of this DNA and so on, it became very clear that there is no genetic background on race. So even in what is particular ethnicity, like black people or South Asians or white people, etc., the amount of genetic diversity within a population is comparable or even larger than the difference between the mean of one population and the other. So there is no genetic base for race. The construct of race is built on all these things like physiological appearance, like skin color, and so on. It has no particular deep basis. So this kind of understanding has contributed to our modern discarding of using like race. Like there has been, I think, a UN convention that called in 1950s or so that sort of made this public proclamation. So discoveries of science can aid the formation of values, but that itself, science itself cannot, I don't think, can provide a value by itself. So one has to have, as humans, we should have other ways of having better values. For example, even if it turns out that it's women and men, suppose they have intrinsically some different abilities. Modern science might be telling that also, but does it mean that they have to be treated differently? No, right? That's because we have a higher value that we imbibe from that, which believes that everyone has to have some same opportunities. So irrespective of whether they have some intrinsic biological differences, I think it's our belief that they have to be treated the same way. So this sort of values cannot be provided by science, but could be inspired by science.
All tough questions. I'll take one question from Zoom, then come back to the audience here. There's somebody on Zoom who's called BAK, who's asking, can you compare scientific temper in India with that in the West, and can scientific method develop in a religious country?
Good question.
I didn't promise you any easy questions.
So usually science and sciences flourished where there is that freedom of thought. Whenever there is authoritarian regimes, typically there could be short-term advancement technology, etc. But in the long-term development of science, at least looking by the history, they have detrimental effects on the flourishing of science.
Thanks. I forget who was Panyal, then Shashwat, right? And then you again. Okay. Then you. Okay.
Yeah, so my question is related to the question that previous person asked. So if you look at history, the development of science and scientific method happened in a particular historical background, basically related to the European Renaissance, where it's not just science or scientific method, but every old ideas were challenged. Like people started talking about questioning the authorities, the idea about freedom, the idea about freedom of expressions, freedom of free thought, and so on. So the non-Western societies somehow, this kind of revolution did not happen. So scientific revolution happened in the background of general European Renaissance. So is it something to do with our culture that non-Western societies couldn't really, the science culture has not seeped into the popular cultures that non-European or non-Western society has?
Okay, so I don't have an authoritative understanding of that. My understanding of history is very limited. But I think different societies have gone through phases in different times, right? When the Europe was in the medieval periods, the dark periods, it was the Arab world that really kept the beacon of science. But now the current Arab world is probably not the beacon of this. So I think different societies go through phases. And in my opinion, I think it just so happened that 400 years ago or so, this Europe went through this period of Renaissance. And it doesn't mean that another 1,000 years Europe would be the beacon carrier of science. It would be some other societies.
Shashwat?
Yes. So you shed a lot of light on how science has benefited humanity and helped progress of civilization and society alike, and how it's a candle in the dark. So my question is about the destructive potential of science and how it has the ability to end everything. So my question is basically, how can we make sure that this candle doesn't burn the entire house down?
Yeah, so what I mean by scientific method is science is a scientific method. our way of creating knowledge based on reason and evidence. And of course, that only provides us a better understanding of the world. But if you have a better understanding of the atomic physics and nuclear physics, one could make a nuclear bomb out of it also. That's sort of a technological application of that. But again, science does not, in my opinion, has an intrinsic value to tell whether one should do it or not. One has to actually, that's why science, the scienticism, some people believe in scienticism, which is believe that there is only science and that you can do everything with science. That is, I don't believe in that. So one has to complement it with a lot of humanitarian values that keep the abuse of technology in check. So we have to burn that candle.
Okay, so I have two questions. One is followed up to Shashwat. When he said that a candle should not burn the house, right? So the thing is, okay, there is a scientific domain and there is a religious domain. Even if we keep it aside, so there are other domains which affect scientific community, scientific development as it has before, like Galileo and some things. Okay? But what about the same things? Like we can't stop the scientific developments, right? But sometimes what happens is those things are lead to something destructive. So we can't stop that. Then how should we limit those things so that it doesn't destroy? That is my one question, that first question. And second one is, there was a colleague I had and he asked me this question, which I was not able to give a good answer for. He said, okay, you are, okay, no offense, okay, even I have worked in LIGO, so it was about LIGO. He said, okay, two black holes and neutron stars are merging and doing that, they're sending gravitational ripples, everything is okay. Okay, you are detecting them, it's okay. But you are building a lot of big instruments like LIGO, okay, you're spending millions of dollars in that. You could have spent that money in other things, like saving improving the poverty of the country, or other things like medicines and all these things. Why should we give you money so that you can waste it? Why does it matter that those two black holes are merging together? What is going to impact to me? Okay, how should I convince that person, okay, this is really important? Because I was not able to convince that means I don't have an answer for that.
Yeah.
So what should I do?
Yeah, I think investing in education and science and research is like buying a medical insurance, right? Suppose you have certain amount of income. You could use all the income to spend on your food or clothes and so on. Or you could kind of distribute so that you spend most of your income on your food and education, etc. But keep a small part of your income for future, for educating your children, for buying a medical insurance, so that in case of an emergency, you will have a backup, etc. So these modern societies have learned this, that investing this on future have given them payoffs in the future. So I think that is a way of justifying our investment in education and science, etc. If you look at as a fraction of our GDP, the amount of the money that we spend on education and science is minuscule. It's not even comparable to many developing countries and certainly not developed countries. So that is not a particularly, I think that, the reason is that historically we have seen that such modest improvement would gain benefit for the future. So it is wise to spend a small fraction of your current money for future. That is the argument I would make. And now, why these large projects like LIGO as opposed to funding a large number of universities, etc.? That's a good question. Okay, one has to have some distribution in this. Because we are, modern science, especially in areas like physics, astronomy, and biology, etc., we are reached a regime that in order to understand, answer some very fundamental questions, one has to have these large machines, large telescopes, large colliders, etc. So if you are totally leaving out this part, we are leaving out our presence in this research frontier. So, but that doesn't mean that one should not invest in small research. There's a lot of exciting research happening there also. Again, it's a matter of what is an appropriate distribution of resources. What was your first question?
First question was about destruction.
Destruction. Yeah. So again, it is ultimately one has to. Scientists are also just like people. They all have very different political views, religious views, and ideological beliefs, etc. And there are people who propagated that you need to have built this bomb and do, etc. Or people who are peaceful and so on. Who, in fact, people like Eddington, I think he refused to participate in the World War I because he had a religious ground. So just being a scientist, I think, is not enough. Well, I think it is important to also have being a good human who value other humans and so on. So one has to have those humanistic values also. In fact, there are scientists who made international associations who work against in the disarmament of nuclear weapons. There is this society of nuclear scientists against nuclear weapons, etc. There are all kinds of organizations where more conscious scientists try to propagate these thoughts.
Even
We'll come back to you. Unless you have a quick follow-up?
okay, quick one.
Okay.
So even if those scientists, like even if they have moral values, there are like political pressures, okay, which affect that scientific development and it leads to destruction.
Yeah.
So how should we limit that?
Yeah, it's very important to have, as a society, we are going outside the domain, but it is important to have independent institutions. Every mature society has these independent institutions. That's why you have to have the government, judiciary, and the press, and the media, parliament, etc. They all provide checks and balances. And in more developed societies, essentially the scientific establishment is sort of self-governed. Like, for example, the US, right? The government does not have a lot of say in deciding the funding priorities in science. They can decide how much money has to be given to the science and etc. But how that money has to be spent in various aspects is primarily determined by the working scientists, like a consortium of working scientists. There's a whole process called decadal survey, this National Academies review, etc. So we are not yet there, but we have some preliminary efforts towards building consensus within the scientific community. And in that sense, it's important to keep the autonomy of various scientific institutions, universities, etc. Because in the long term, they are in some sense the gatekeepers of society. It's important to have those independent voices heard and survived.
Thanks. The person with the mic and then the person in front.
So my question is very simple. As youngsters, we are trapped in the black hole of consuming junk, whether it is social media or fast food or anything junk food. So, apart from this religious aspect or political aspect of science, don't you think that we should gravitate more towards the food science? Because it depends on life expectancy, and if you want to do more research, we have to live. So, food science is important. Don't you think that it is important to be conscious about food science?
Yes.
Yeah.
So like I think you have sort of answered my question. My question was going to be, so like we know that the great filter hypothesis is about whether or not a species is going to last long enough to detect other civilizations. So like the last filter is basically the destruction of a species by the advancements of the large-scale weapons, which humanity has already reached that level by having nuclear weapons and stuff. So like basically my question was going to be like how likely are humans to continue surviving till we find some other species out there?
Hard question.
All lot of simple questions thrown at you.
It's not a simple question. But I think, again, while it is easy to imagine these sort of sudden deaths by large-scale weapons, etc., we should also be worried about the slow death by various things like climate change and so on. Again, it is probably even likely that the entire human race won't be wiped out. But what is almost certain is that a large fraction of the societies would suffer. And the unfortunate part is that these people may not be the ones who primarily contributed to these changes. Because if you look at that, the people who drive this climate change are the more developed societies, and within that one, the more developed among them, etc. But people who would suffer first are the least privileged ones. So there is a large unfairness in the cause and the effect.
Rajul?
Yeah. So we usually try to frame science as it will produce something useful, like I don't know, electricity, communication, and all that. But I think it's a wrong way of pushing for science. We should just push it as science is this pursuit of knowledge, like arts we have, because we are not pursuing arts for any particular usefulness. Maybe it just gives us a sense of living this world. So because if we try to do that, I believe that's the case, and you can comment on it. If we try to push science as technology or usefulness, then the government, who are the main funding bodies these days, will not only look for what is politically useful for them or what can militarily be useful for them in that respect, and then the funding will be aligned in that respect. That's what happened, I believe, during the Second World War, and all the technologies were developed in that respect, and the science, of course, benefited from that funding. But I believe it's a wrong direction that we are taking. If we're always going to say that science will provide you some useful technology which we can use. So please comment on it. That's my view.
Yeah, it's a very good question. Right? Again, it's not. I don't know what is the right way to push. I think you should probably do both, because one, if you say this, one could get this kind of arguments that you got, right? What is I'm very interested in knowledge and beauty and so on, but I have this more important problems to solve, like poverty. So how is it justified that you are spending this money on knowing about black holes while people are suffering? So one has to make a combination of the science. But I totally buy your point that the purpose of science is not only to produce technology; it has a much larger value.
So we fund arts also.
Yeah.
Though it's not helping poverty.
Yeah. But
it can be of the same amount, I would say that.
But to be fair, the public funding on art is much smaller than the public funding on science.
The private funding in art is much more than the
Yeah.
private funding of science.
Yes.
Right?
Yeah.
But there are also other enterprises like sports industry, for example, or music.
Yeah.
They don't have utilitarian values, right?
Yeah.
But the society still.
Absolutely. No, so I totally agree. One should argue that there is the intrinsic value in creating knowledge. That is true.
I think that's why it goes back to what you initially said.
Yeah.
Right? If you look at hyper-utilitarianism, can the mic be turned off next to you?
I don't have it.
It's off.
It's for mine.
Somebody's snoring. Can hear. No, so this hyper-utilitarian view of all human endeavor leads to this problem exactly, where you're forced to account for why everything you do is useful in purely monetary or capitalist terms, right?
Yeah.
But then we go back to your original concept of scientific temper, how scientific temper and method is not just confined to science alone, but it's also it's an application to life around you, in which case you apply scientific temper, scientific method, Occam's razor to things around you, to social science, to humanities, to how you live, and I think that's part of the utility. I mean, part of the charm or the I want, what's the synonym for utility which is not capitalist? I can't think of any. Part of the charm or the benefits of promoting science for its own sake, right? Would you agree?
Absolutely.
Yeah. Other questions here?
As Sir mentioned, that science and religion is not contradictory, right? So, as religion deals with love, empathy, harmony, respect, etc. So, these values are also included, holded by the scientific temper, right? So, I would like to know the comment. Isn't it seems like contradicting?
No, there's no contradiction. So I'm not sure whether these are values are part of what is called scientific temper. But I would view a scientific temper is to look at a method to look at a problem based on evidence and reason.
It's also include like logical and rational thinking.
Yeah, that is very much. Reason and logic are very much part of the scientific temper. But things like empathy and love are not necessarily part of scientific temper, but they're in no way conflicting with scientific temper also. And that's why I said they are different domains. But one, just one is not enough. One needs to have other things also. So, for example, the scientific temper is not enough. One has to have other humanitarian values like love and empathy also.
It goes back to what you said about scientism, where the belief is that science and scientists know everything about everything, and if you leave it to them, if you form a government of technocrats and engineers, everything will be great. That's an extremely dangerous notion.
Exactly.
So, for precisely this reason.
Yeah. Most of the time, the solution to societal problems is not necessarily in technology. One has to have some other reason. So I remember, for example, I happened to be in some meeting a few years ago where a very famous international IT company was trying to argue for self-driving cars. And this person made a very passionate speech about how there are so many traffic accidents in India and how we can solve them with self-driving cars. Of course, there are traffic accidents in India, but there are probably much better solutions to that, much cheaper solutions to that than self-driving cars, right? So one does not before thinking about a purely technological solution, one has to look at the problem in a wider context.
Exactly. So scientific method as opposed to science being primary is exactly what it is.
Yeah, it is precisely the question. What is the problem? What is the most reasonable way of solving it? This is scientific method.
Solution may not be science, but scientific method.
Yeah.
I think that's an important point.
Just to add.
No, did you have to?
Just follow.
Okay,
yeah. So that's all the more reason to also take science to public and make public also the stakeholder of what's going on, whether it's making the right policy. So that's where the role of democracy and science kind of converge together to make informed decisions which are for everybody's good and avoid catastrophic ones.
Yeah, scientific temper is linked to democracy directly.
Yes.
Right? Yeah.
Sir, you have mentioned before that the religion and the sciences both are two different domains, right? In our current socio-political situations, students in our country are being taught that the very first spaceship was Ravana's Pushpaka Vimana and some A4 Aranyakanta, U4 Uttarakanda and all. And students are being taught that the cochlea of the the child inside the womb is being developed 20 weeks before. That's why the son Abhimanyu of Arjuna and his mother, Abhimanyu heard the conversations between his father Arjuna and mother. All these kind of myths are being taught to the students of our country. What do you think? Will this laws diminish the scientific temper and the scientific progress of our country? I would like to know what your comments.
Good. Clearly, your answer is the question itself. Yeah, no, I agree with you.
I would like to know what are your comments on.
No, I agree with you.
Okay, sir, thank you.
I think it goes back to this last example of history being the domain of history.
That's right, yes. But essentially, what is happening is there is a conflict between the evidence and the ideological reasons. And often these forces would, they would put whatever convenient things, even though it is against the evidence. That is happening, unfortunately.
Other comments? Also, people on YouTube and Zoom, please type in your questions if you have any. Other comments, questions? It's rare that we have such discussions in the Science Institute. I'm very happy that we are having this and and it's gone more than half an hour. It's important that Science Institutes have these discussions and not just talk about, equations and data analysis, but it's important that we talk about what it is to do science, what it does mean to be scientists in the public domain, in society. So I think it's important to have these discussions. Other questions and comments? Yes.
Just a quick follow-up regarding that one. So, what do we do to, sort of scientifically challenge or scientifically keep ourselves based on a scientific method when this very thing starts seeping into the scientific world, so some parts of the scientific world itself?
Yeah, see, I think one very interesting example from other societies or even this. So, for example, until very recently, Indian scientists, as self-criticism also, were rather living in their elitist ivory towers. Right? They were not, except for some notable examples, as a community, we were not so much into interfacing with the society. If you look at, for example, and it's probably true for most of the world, if you look at the in different countries, who are the most scientists who are the most engaged with the wider society? In the US, for example, it's the evolutionary biologists. For example, Stephen Jay Gould has written many, many interesting books that explain the science of evolutionary biology for the wider society, because his science was being questioned. There are very interesting books on climate change written by interesting climate scientists, because their science was being questioned. There are very interesting books on Indian history written by people like Rabindranath Thapar, Vipin Chandra, etc., because they had a responsibility for explaining their scientific understanding of Indian history. So I think until very recently, the Indian scientists did not need to do that because they were sort of their safe zones. But now we are reaching at a region where we are sort of bound to explain our science to a wider society. We are bound to communicate what we do. Because after all, we are also funded by the taxpayers' money. It is our responsibility to explain what we do to science also. But if at all, and my understanding is there is a lot of excitement in the society to understand about latest discoveries of science, etc. There's a lot of excitement and pride and so on that you see in the media and so on. But if there is at least one thing that everyone should know about science, is the scientific method, in my opinion. It's not very difficult. It's just a way of addressing a question based on reason and evidence. Does it make sense? Is it supported by evidence? One could ask this question to any claim that you see. And if people start to do that, then a lot of this false propaganda, fake news, and all this would not take grip in the society. So I think one thing that we do as scientists is to communicate better to our society, and not only the science what we do, but also the basic of thinking about the world. It's not about science. It's just a way of looking at a problem and in a logical and reasonable way, and looking for evidence on any claims. For example, there is this Carl Sagan's book has this very interesting thing called a baloney detection kit. There's another 10 things or something. Whatever you see a claim, you could do a checklist of going through the 10 things to see if that makes sense. And so on. So these are things that I think everyone should learn and practice.
Okay, I have one question here.
What is your opinion on application of Bayesian logic to reducing conclusions in social or media? What is your opinion on using Bayesian statistics to draw conclusions in social sciences and political sciences? Does it help in drawing correct conclusions? And using those Bayesian statistics, can one ask correct questions as well? Is it possible to
So I don't have any informed opinion on that. But I think Bayesian method is inference is a very general method, right? You're splitting your evidence ratio into two things. One is that there is a prior belief, and there is a likelihood. Suppose you are making a new claim that is contrary to a large amount of existing evidence. For example, someone is saying that the Earth is actually flat, not round. We have an enormous observational evidence saying that the Earth is flat. If you want to believe that the Earth is flat, then there has to be a great amount of observational evidence supporting this claim. It will change it. But if you are doing something that is somewhere maybe the universe is spatially flat or not, maybe our prior evidence is not that great. So maybe if you get some significant evidence on something, it will change it. So these kind of things could be applied in social science also, but I don't know the level of quantifiability, because we're dealing in social science, we are doing with a much larger amount of complexity in your problem.
Like, for example, if I ask you, like, do you believe in a 20 rupee note? You can always say that I believe in a 20 rupee note given that it is signed by the government of India. For example, that's the simple logic.
Yeah, absolutely, yeah.
So next question I can ask is like, how does that, why do you believe that government signature? Then you say I believe in a government, then the next step of logic would be like, I would believe in a particular economic system.
Yeah.
Then one has to ask a question like, why do you believe in that economic system? Wherein the logic fails.
Yeah.
No.
No, but those are.
You can buy worth 20 rupees something, right? Yeah. Worth. What bigger evidence you need to believe in a 20 rupees note? And it can give you something worth 20 rupees.
No, that is the thing. Like, why you can buy something with the 20 rupees?
People can't give you.
Because somebody guarantees it. You cannot buy that with a seashell. No.
No, but that is based on what a lot of economics and philosophers are called would say is consensus. Right? There's a consensus. We all agree. Money works because we all agree it works. Once we are, why is there a run on the bank and then banks collapse? Right? They work because we believe, because we agree it works. It works. It's
as a nation, we agree to follow.
It's a bit like that. Also, going back to your Bayesian, Carl Sagan famously said, extraordinary claims require extraordinary evidence. That's the base theorem put in words in some sense, right? And many of us, of course, have grown up reading foundation series of Asimov, where Harry Seldon tries to apply this to social sciences. Did you have a follow-up question? Okay. Other questions, comments? Yeah, comment.
So I wanted to ask one thing, that sometimes nowadays I feel that we are much more focused on technological implications, so that we are like, even if you see scientific community sometimes or the common people, okay, they are much more focused on technological implication rather than science sometimes. But if you take physics, it's just a natural explanation in the language of mathematics. Okay? Don't you think sometimes we should focus on understanding pure science? We should focus on pure science rather than technology. Because then, like what are we doing? Like sometimes we think, okay, are we engineers? No, we don't want an application. Okay, technology applications will be followed up by science. That is true, but we should more focus on science, right? What do you think?
Yeah, I think there should be room for both. There should be a room for doing blue sky research, because it is part of our quest to know more. And many a time, if you look at the history, this knowing has other implications also. One through technology, and also by it helps change the world. So I think there is room for both type of research, but unfortunately there is this bias towards very applied research where you look for immediate applications. So for example, and it is not only in India, also there's a worldwide change. So for example, I'm part of LIGO, so one thing that resulted in this remarkable success of LIGO was that this National Science Foundation funded this a few $100 million experiment for about 20 years without a result before it hit the goal, right? So there was a vision in the funding agencies that such a pursuit would take a long time and it's worth doing it. And a lot of people believe that in the current world, such a long-term investment would not happen, because priorities have changed everywhere in the world. But that is not really healthy for the long-term advancement of technology.
So I have another question. That is the last question. So it's about the title, okay, A Candle in the Dark. Yes. So sometimes I feel, okay, if you look at the quantum field theory, okay, so it says that a particle is just a fluctuation in the fields. Okay, we take different fields. So if you look at from that view, we can say that, okay, if the particles are just an fluctuations, okay, and they make us, okay, so it sometimes like takes me into the dark that, okay, why does it matter then? Because matter is just a fluctuation. We are just a fluctuations. sometimes rather than giving a bright light, okay, it sometimes takes us into dark. Okay, what should we do now? So at those points, what should we do? Like, and you got my point.
We moved squarely into philosophy. Yeah, please.
No, I don't think I have an answer. See, but so this is, there are two levels of, I have no answer to it. I have no power of answering this, but related thoughts. How do, for example, scientists think about this thing, right? So we know that we won't know the truth. We will never know the absolute truth. But we still function with these tentative explanations, these approximate theories, because they are useful. So we make some useful things because even though we know that's not perfectly right or to be true. So in the same way, we know that as personally, I'm thinking of my philosophy of life, which is that we know that we are not eternal. We will be dying maybe tomorrow, or 10 years or 20 years. But still, it is possible to find some meaning to your life. And that's one's own choice. So one can do that by keeping the tentative nature of our life, just like science work with the tentative nature of the truth theories.
Any last questions, comments? Yeah, Sumanta.
So you mentioned about us reaching out to the public, but will the public really understand us? The question is, how do they even look at us? I mean, because what I have gotten an impression of is just that sometimes when they look at us, they think that we are just writing and scribbling things in papers that they do not understand, and we are getting funding for it. Other side, I have a suspicion that they are looking at us like we are some kinds of strange wizards who talk in about terminology and so on. And science is full of a lot of terminology, so we become impossible to understand to them. The only difference from wizards they read about in storybooks and us is that we cannot shoot lightning from our fingers at them or cast storms or spells on them or something like that. And in short, sometimes otherwise, I have actually gone through this experience myself, that somebody just found, knew that I had a PhD in physics. He knew I was effectively a scientist. So he just said that, hey, do you know how to fix this machine or that machine? I told him that, do you think I'm not a mechanical engineer? And then when he found out I could not fix his problem, his attitude was solely like, then what kind of education did you receive? And then, well, I just don't know how to put it more politely. I resisted every urge to respond to him with vulgar gestures. But it's just that this is a slight problem. It's that somehow, it's like we have got to get across the divide with the public. It's like somehow there's a communication problem, and I think we need some kind of people who can help us with that. Yeah. That is mainly the problem of a lot of scientific terminology that we start using, which makes it impossible. For example, if someone asks us what we do, then if we try explaining it to them, like as he was mentioning here, that was a matter of black holes and why we are studying. What was your question again?
Yeah, those are merging together.
Yeah.
What does it matter?
Yes. So it's like if we try to explain it, then it's like they will not understand. Perhaps they won't understand, or perhaps they will not understand why we should care.
Yeah. No, this is a big question, right? So I think we should meet them halfway. That is my philosophy. Just like you ignore some complexities of the L3 and L4, right? Because it is also clear that not everyone would care and not everyone would understand. But the society has different stratas, right? There will be some fraction of people who would have some interest in science and knowledge, etc. So they are our friends. They are the friends of all friends. So we should be talking to them. And again, we should be meeting them halfway, because it's important to kind of communicate. That's why it's important to have a science communication program. And it itself has its own theory, because as scientists, we are concerned about what we do. We won't know what is the best way of communicating this. But with experience over the last few decades, people have evolved some understanding of how to do it best. Again, it's a changing progress. It's a work in progress also. That's why it's important to talk to people like Dheeraj and see who would help you how to kind of translate your work to some more human readable language, right? That's why it's important to meet them halfway. It is a process that involves both sides, and both of us has to make that effort.
That's last comment or question. Then we'll stop.
Hello, sir.
Yeah.
So I was just curious. So the idea of creativity or creative is very abstract, and it is mostly applied in the area of arts. So when we come to science, and we can actually solve a lot of problems being creative in science area. So how do we fit this idea of creativity or creativeness in the scientific method, let's say? So what do you think about it?
Yes, absolutely. I think I totally believe that science is as creative an enterprise as art is. The only difference that the nature of creativity has some difference. So I think, again, quoting Carl Sagan, I think Carl Sagan said, science is a marriage of skepticism and imagination. I think like that. One has to have a combination of these things. So, so that way of forming ideas, it is just like, I think that works just like art. But not every great idea works in science. There is an ultimate touchstone, which is the world around us. So how beautiful theory it is, it wouldn't work unless it can explain the natural phenomena. So one has to have that combination of imagination and skepticism.
So one more thing, just another question. So when we look into scientific methods, we have like in the beginning you mentioned in the material world, so we can only explain the material aspect and material world of it. So there is a limitation to human, if there is a limitation to humans' ability to unreveal the natural phenomenon. So in that case, so what do we do?
So that is understood that the science, we will never reach the absolute truth. We are just improving our explanations. And as Karl Popper was saying, a current explanation, a theory could leave way for a more gentle and more accurate way. So we are always working with tentative explanations. We will, unlikely we will ever reach a full understanding of the world around us. But it is a pursuit. But even with that partial understanding, it is useful.
Right. Thanks.
I think we'll stop there for now. He also has a long way to get back to
another city.
Etc. So thanks again, Ajith, for a wonderful talk which kind of symbolized what Science Day was about, and for leading to a very, very vivid discussion of topics which people usually don't get a chance to talk about here. Thanks again, and we'll get you again here. Maybe next time we can actually talk about gravitational wave physics, but I think we'll rather have you talk about all this instead next time. So thanks again, and thanks for everybody for being patient audience here and waiting for so long.
Thank you. I also greatly enjoyed this discussion. Thank you very much for this online.